Welcome to This Explainer. If you ever pull up one of those global flight trackers at around 8 p.m., you are going to see something genuinely mesmerizing happening right over the North Atlantic. It's like the map just comes alive. You've got this endless glowing stream of wide-body jets. We're talking 777s, A350s, Dreamliners, all leaving cities like New York, Boston, and Toronto, pointing their noses straight into the pitch-black night sky and heading for Europe. Okay, let's dive into this because honestly, it is absolutely fascinating. Try booking a daytime flight to London or Paris, and well, you're going to be searching for a while. There are barely any. This massive, coordinated midnight migration, it is definitely not a scheduling accident, and it's for sure not just some random quirk of time zones. Almost every single eastbound transatlantic flight is purposefully, precisely engineered to fly in the dark. To understand exactly why, we're going to peel back the onion on this phenomenon. The midnight rush is actually driven by 4 layers of global synchronization: high-altitude atmospheric physics, multi-million-dollar airline economics, dynamic air traffic control, and strict European noise laws. Let's start right at the top. Layer 1, the jet stream and fuel mathematics. So 30,000 feet up, right above those dark ocean clouds, there's this high-velocity ribbon of wind flowing west to east. We know it as the jet stream. And at night, because the ground cools off so quickly, the temperature contrast between freezing polar air and warm equatorial air sharpens dramatically. And this brilliantly illustrates the result. That contrast acts like an atmospheric supercharger, whipping the wind up to a staggering 200 miles per hour. When airlines schedule a 10 p.m. departure, they are aiming directly for this massive tailwind. What does that actually mean in reality? Well, just look at the flight durations. If you're slogging westbound against that wind, it's going to take you about 8.5 hours. But eastbound, riding that supercharged night wind, you are doing the exact same physical crossing in just 6 hours and 15 minutes. Literally, riding the night sky shaves a full hour and 15 minutes off your trip compared to fighting the headwind. And in aviation, time isn't just money, it's jet fuel. A massive wide-body plane burns roughly 5 to 6 tons of fuel every single hour. So by shaving 75 minutes off a crossing, an airline pockets anywhere from $15,000 to $25,000 in fuel savings on just one flight. Multiply that by the thousands of flights crossing the ocean every single year. Timing the night sky saves the industry hundreds of millions of dollars annually. So that brings us down from the clouds and straight into the accountant's spreadsheet. Layer 2, aircraft utilization and turnaround economics. Now, what's really interesting about this is the stark financial reality. An airplane only makes money when it's up in the air. A $60 million jet just sitting on the tarmac is pure financial deadweight. Think about the time zone puzzle from New York to London. London is 5 hours ahead. If you fly out of New York at noon, you land in London at midnight. Public transit is closed, the airport is mostly asleep, and that phenomenally expensive asset just sits there, completely useless, for 8 hours. But if you leave at 10 p.m., you land at 10 a.m., perfectly lined up for the day's operations. Let's walk through just how ruthlessly efficient this is. The plane lands in London at 10 a.m. local time. Boom. The ground crews are fully staffed and ready to go, and they spend just 2 furious hours cleaning, refueling, and restocking. By noon, that exact same aircraft is back in the sky, generating revenue on a new route back across the ocean. By sticking to the night, airlines turn a pesky time zone difference from a logistical nightmare into a massive, money-making asset. Moving right along to the infrastructure that makes this all possible. Layer 3, invisible sky highways. Here is the catch. Flying over land is one thing, but the middle of the Atlantic is a giant radar dead zone. Radar signals just can't reach that far out over the water. So to keep everyone safe in the pitch black, controllers use the North Atlantic track system. It's essentially a set of invisible sky highways, and air traffic controllers in Gander, Canada and Chinook, Ireland actually recalculate these routes twice a day just to safely choreograph hundreds of these heavy metal tubes over the ocean without standard radar. So the crucial point is how this system completely dictates the schedule. The eastbound tracks go live in the late afternoon. The optimal window to catch these custom-built highways opens up at 6 p.m. and absolutely slams shut by 1 a.m. If an airline misses that tight window, no way. They lose access to the most direct routes and get pushed out to longer, way less efficient flight paths. Which brings us back down to earth for our final piece of the puzzle. Layer 4, curfews and passenger psychology. No matter how ridiculously fast that jet stream is blowing, airlines still have to answer to the law. Massive European hubs, places like Heathrow or Charles de Gaulle, operate under incredibly strict noise curfews to protect the millions of people living nearby. They flat out ban heavy aircraft landings between midnight and 5 a.m. Show up too early, the airline gets hit with massive financial fines, or they could even lose their landing rights altogether. Let's move on and see how this builds, because airlines actually have to work the math backward. That legal morning landing window in Europe opens exactly at 6 a.m. So if you factor in the 6 to 7 hours of flight time zipping along on that fast nighttime jet stream, it strictly dictates your departure. Planes absolutely must leave North America in a very narrow window, basically between 9 p.m. and 11 p.m. Eastern Time. And in a totally beautiful twist of fate, this intensely engineered schedule happens to perfectly match what we actually want as humans. It's the classic red-eye preference. Business travelers and tourists overwhelmingly prefer to board at night, catch a few hours of kind of questionable airplane sleep, and land at dawn with the whole day ahead of them. It absolutely beats burning a full day staring at a seatback screen in a metal tube at 38,000 feet, right? So, the next time you're sitting at the gate at 10 p.m., sipping a coffee and waiting to board a flight across the ocean, I want you to remember this explainer. You aren't just taking a trip. You are actively participating in a flawlessly synchronized global network, one shaped by the physics of the atmosphere, air traffic geometry, high-stakes economics, and local noise laws. Every single minute of your journey was calculated long before you even clicked buy on your ticket, which really makes you wonder, doesn't it? What other invisible global systems are quietly dictating your daily routines without you even realizing it? Thanks for exploring this with me, and I'll catch you in the next one.